Well, now in our today's topic, kinematics is continuing, and our continuation with the motion in plane, and the topic is projectile motion. We have to discuss more about the projectile motion, the range, the vertical height, the component of velocities, etc. Well, now projectile motion, we have to discuss about what is basically a projectile. That is a particle whose acceleration is zero, but there is some initial velocity, that is a projectile. And the path traced by projectile is called trajectory. And when the particle is projected from a certain height, then it starts coming down after some movements under the action of gravity. So the horizontal distance covered by the projectile is called range. Now, first of all, our discussion is regarding ground-to-ground projection. That is, we consider the motion of a bullet which is fired from the gun. Obviously, the bullet will move horizontally. Its initial velocity makes an angle theta with the horizontal. X-axis and y-axis are taken as the horizontal and the vertical components, or x-axis along the ground and y-axis along the vertical. So once more I will repeat, that is, the motion of a bullet is to be considered, that is fired from the gun. Its initial velocity makes angle theta with the horizontal. If initial velocity is taken as u and angle of projection is theta, then horizontal component will become u cos theta and vertical component will become u sin theta. U can be resolved as ux and uy. Ux will be u cos theta, that is along the horizontal direction, and uy will be u sin theta along the vertical direction. Therefore, the bullet can be resolved into horizontal and vertical components. The horizontal component of initial velocity is u cos theta, and the vertical component of the initial velocity is u sin theta. In horizontal direction, there is no acceleration, so it moves with constant velocity, and this velocity is given by function Vx is equal to ux is equal to u cos theta. If the angle of projection is not given, then in that case Vx and ux will be equal. But now here the angle of projection is theta. Therefore, we have taken the velocity constant along x-axis is ux is equal to u cos theta. Distance traveled in time t is given as x is equal to ux into t, or x is equal to, for ux we have computed the value in equation number 1. That value is u cos theta multiplied by t, and from this equation t is calculated by function x over cos theta. Now in the given diagram, we find that OX is indicating the horizontal component of the initial velocity, and OY, that is the vertical line perpendicular to x-axis, is indicating the vertical component of the initial velocity. The angle of projection is theta, and u is supposed to be the initial velocity. Ux means initial velocity along x-axis, uy means initial velocity along y-axis. These components are ux is equal to u cos theta and uy is equal to u sin theta. When body reaches to the highest point, vy equals to 0. And the distance from horizontal to the highest point is called the maximum height of the projectile, and the particle which is moving from O at angle theta is called a projectile. So when it attains the maximum height, it starts coming down. The distance O to x is called the range. Moreover, in the adjoining diagram, the right hand side, while the body is going up, that is vertical component will be u sin theta, and we will find that at the highest point the velocity will be 0, and then it will start coming down. Therefore, we have taken ay is equal to minus g. The motion in vertical direction is same as that of the ball thrown upwards with initial velocity uy equal to u sine theta and acceleration minus g. The point is that the time of ascent must be equal to the time of descent. So at time t, the vertical component of velocity Vy will be Uy minus Gt. Normally, rule is that acceleration due to gravity is negative or positive depending upon whether it is going up or coming down. So when it is going up, we find it is minus g, so we have taken Uy minus Gt. Now we have to take the component of Uy. Uy is the component of the initial velocity along y-axis. Therefore, equation number 2 is written as that Vy is equal to u sine theta minus gt. Now, displacement along y direction is y is equal to u sine theta into t minus half gt square. This is equation number 3. The point is that this equation we have taken in reference to the general equations of motion, that is displacement is ut plus half gt square. But the body is going up, so we have taken as minus sign, and instead of taking ut, we have taken the component, and that is u sine theta. Therefore, u sine theta, the vertical component, is multiplied by t minus half gt square. Now, we are substituting the value of t from equation 1 in equation 3. So it is purely a case of elimination and substitution. We are eliminating t and the value of t is substituted in equation number 3. And from this we get the vertical displacement y, that is u sine theta into x over u cos theta minus half g into x over u cos theta whole square. Now from this equation, we get y is equal to x tan theta minus g over 2u square cos square theta x square. This is the equation of parabola. This is indicating that when a body is projected, then the direction of projection, that is at a specific angle, theta, the body projected is called a projectile. The path traced by projectile is trajectory, and the trajectory of the projectile is parabola, because the vertical distance y is given by this equation, that is x tan theta minus g over 2u square cos square theta into x square. This is basically an equation of parabola. The trajectory of projectile is parabolic, as I have explained you earlier. The projectile will rise to the maximum height, where Vx will be u cos theta and Vy will be 0. That is, at the highest point, the velocity will be 0, but the horizontal component will be u cos theta. And then, moving down again to reach the ground at a distance r from the origin, setting x is equal to r and y is equal to 0, since projectile reaches the ground again. Now, from the various calculations, we will put the value 0 equals to r tan theta minus g over 2u square cos square theta into r square. In this equation, r will be the range and theta will be the angle of projection. And if we write u cos theta, that is the horizontal component of the velocity. Now, from this equation, we get the value of r. That is, r is taken out common and simplified the result. So it will be 2u square cos square theta over g, and then we have written sin theta over cos theta. From numerator and denominator, if cos theta will cancel off, then 2 cos theta sin theta will be written as sin 2 theta. So we have written r is equal to 2u square over g sin theta cos theta. This is the value of range, and 2 sin theta cos theta is replaced by sine 2 theta. Therefore, the equation becomes r is equal to u square sine 2 theta over g. In order to understand these all compositions, the trigonometrical calculations are used. Now, in the given figure, again, the point of projection is O, theta is the angle of projection, and the body which is projected is called projectile, and in between two arrows are indicated horizontally and vertically. They are the components of the velocity. Vx is u cos theta, that is horizontal component, and Vy is u sine theta minus gt, that is the vertical component. Now, the body is coming down, and we find that the distance from O on the x-axis represented by r, that is called range. So 0 is equal to u sine theta minus gt, and Vy can be taken as uy minus gt. G is taken negative when the body is going up and finally coming down. If time for upward journey is t at the highest point, Vy is 0. So 0 is equal to u sine theta minus gt, where u sine theta is the vertical component of velocity. Now, because Vy is equal to uy minus gt, therefore time can be calculated by equation t is equal to u sine theta over g. Again, the same figure is depicted as I have earlier explained. Now, capital T is the total time of the projectile, that is, the time of ascent and time of descent are equal. So, if the time of ascent is small t, time of descent is also small t, then the total time is equal to 2t. As it will take some time for the downward journey, the time of flight is given by function 2u sine theta over g. Now, in this given figure, the projectile motion is depicted. That is, body is kept at a certain height from the ground, and the body is to be launched from that height. Body is coming down after projection. This body is called a projectile. The path in which the body has come, that is called the trajectory of that body. The body is taken in the form of a rock. The initial velocity of the rock is 45 meters per second, and the angle of projection, that is 60 degrees. Now, coordinate axes are drawn. The dotted line is indicating the y-axis, and another axis, that is x-axis, the horizontal axis. So velocity can be resolved into two components along x-axis and along y-axis. And here we are finding that angle of projection is 60 degrees. Blue line is indicating the path of the projectile, that is called trajectory. And y and x-axis are called the components of the velocities. The vertical component is 45 into sine 60. The horizontal component is 45 into cos 60. By putting the values, we get the values for cos 60 1 by 2 and for sine 60 root 3 by 2. And from this figure, we need to find the horizontal and vertical components of the final velocity. Now, in this figure, the distance from origin towards the green arrow downward, that is called the range, and that is called the horizontal range, delta x.